There's a tree that held the desert's oldest secret. For 4,000 years, its golden pods fed civilizations where nothing else could survive. It produced a sweetness that required no plantation, no slaves, no water beyond what the sky gave sparingly. It healed the land while feeding the people. Then, in less than a century, it was nearly erased, called a weed, declared a pest, burned, poisoned, and ripped from the earth by machines designed specifically to destroy it. The United States government spent millions trying to eliminate it from existence. But beneath the surface, something was waiting. Deep roots that remembered, seeds that refused to die, and knowledge that survived in the hands of people who never forgot what the tree had given them. This is the story of Mesquite, the tree that sweetened life before sugar existed and may hold the answer to what comes after. The food that fed empires now abandoned, the medicine that healed bodies now dismissed as worthless scrub, and the systematic erasure of a food source so valuable that its return threatens billion-dollar industries built on scarcity and dependence. Welcome to Veiled Earth, where we uncover what was deliberately buried. The seeds that refused to die. The archive opens in 1998, Tucson, Arizona, a cave system on the edge of the Sonoran Desert. Archaeologists brushing away millennia of dust from sealed clay jars. Inside, they found seeds, small, hard, glossy brown beans that looked almost modern, as if they'd been stored last season, not 40 centuries ago. Laboratory analysis confirmed what seemed impossible. These seeds were approximately 4,000 years old, placed in these jars during an era when the first cities were just rising in Mesopotamia, when Stonehenge was still being built, when bronze was the cutting edge of technology. The people who stored these seeds had no written language. They built no monuments that survived into our era. History doesn't record their names, but they understood something we forgot. In a land where corn withered and rivers turned to dust, mesquite still gave fruit, and that fruit was worth preserving with the same care they gave to their most precious possessions. The seeds themselves tell a story of evolutionary genius. Their coats are thick as pebbles, harder than most modern crop seeds. This thickness isn't a flaw, it's armor. Protection against heat that can exceed 120 degrees Fahrenheit, against insects that would devour softer seeds, against decay that claims most organic material within decades. When researchers planted some of these ancient seeds, they didn't decompose, they germinated. After 4,000 years of dormancy, the life force within them remained intact, ready to continue a legacy that predates written history. Modern seed banks, with all their technology and controlled environments, struggled to keep seeds viable for a century. These seeds survived 40 centuries in a desert cave with no human intervention beyond being placed in clay and sealed from light. This longevity isn't unique to these particular seeds, it's characteristic of the species. Mesquite seeds routinely remain viable for decades, even centuries, in the soil, waiting for the right conditions, patient beyond human understanding. This is survival strategy perfected over millions of years. Because mesquite didn't evolve in a stable environment, it evolved in chaos, in drought, in fire, in conditions that killed everything else. And it learned to wait. Archaeological sites across the Sonoran Desert tell the same story. The Tucson Basin, the Santa Cruz Valley, the Gila River watershed. Everywhere researchers dig, they find the same evidence. Charred mesquite pods in ancient hearths, grinding stones worn smooth from processing millions of pods. Storage pits lined with mesquite seeds, entire layers of archaeological strata marked by mesquite consumption. This wasn't supplemental food, this wasn't emergency rations, this was foundational, as central to desert agriculture as wheat was to Mesopotamia or rice to China. The people who lived here built their entire food system around a tree that required no cultivation, no irrigation, no human intervention beyond harvesting what fell naturally. While other civilizations were developing complex agricultural systems that demanded constant labor, massive infrastructure, and favorable weather, desert communities had already solved the problem differently. They partnered with a tree that did the work for them, that survived when everything else failed, that gave freely without demanding anything in return. The tree of life. To understand what was lost, you need to understand what mesquite actually is, not the scrubby pest that ranchers learned to hate, but the tree that indigenous peoples called family. Mesquite belongs to the genus Prosopis. There are approximately 44 species worldwide, growing in arid and semi-arid regions across every inhabited continent. In North America, The primary species are Prosopis velutina, Prosopis glandulosa, and Prosopis pubescens. But scientific names don't capture what the tree means. For the Tohono O'odham, it was Kui. For the Pima, it was similar. For the Yaqui and Seri, it had other names, but the translation was always the same. The tree of life. Above ground, mesquite doesn't look particularly impressive. In harsh conditions, it grows as a shrub, multi-trunked and sprawling. In better conditions, it can reach 30 feet tall with a canopy spreading 40 feet wide. The leaves are small, compound, almost fern-like. The bark is rough and dark. The thorns are vicious, capable of puncturing tire rubber. But the real tree isn't what you see above ground. The real tree is below. A mature mesquite's root system can extend over 160 feet deep. Some documented cases show roots reaching 200 feet into the earth. That's deeper than most water wells, deeper than drought ever reaches, deeper than any crop plant can dream of growing. These aren't just anchors, they're hydraulic systems. Through a process called hydraulic redistribution, mesquite roots pull water from deep aquifers during the night when the tree's water demand is low. Then during the day, they release some of that water into the shallow soil layers, where the tree's own feeder roots can access it. The tree literally waters itself, creating its own oasis in the desert. Scientists estimate that a mature mesquite's root system can store up to 600 gallons of water. That's enough to survive 10 dry summers, enough to outlast any drought in recorded southwestern history. And this water doesn't just benefit the tree. Other plants growing in mesquite's root zone gain access to moisture they could never reach on their own. The iconic saguaro cactus often cannot survive its first decades without growing under mesquite's protection. Then there are the pods, the fruit that made mesquite invaluable to human survival. Mesquite pods look like elongated green beans, 4 to 8 inches long. When ripe, they turn golden brown or reddish, depending on the variety. They fall from the trees in massive quantities, carpeting the ground during peak harvest season in June and July. Each pod contains 10 to 30% protein, comparable to soybeans. The carbohydrate content is approximately 50%. But here's what makes mesquite extraordinary. That sweetness comes primarily from fructose and sucrose, bound in a matrix of soluble fiber. The pods contain up to 35% natural sugar. That's sweeter than apples, sweeter than most fruits, sweet enough to satisfy the human craving for sweetness without any processing. But unlike refined sugar, which spikes blood glucose and crashes energy, mesquite sugar is wrapped in galactomannan gum. This soluble fiber forms a gel in the stomach, slowing digestion and absorption. The result is steady energy release over hours, not minutes. The glycemic index of mesquite flour is approximately 25. For comparison, table sugar is 65, white bread is 75, even whole wheat bread is 55. This means mesquite provides sweetness without the metabolic damage. It feeds the body without destabilizing blood sugar. It satisfies without creating the addiction cycle that refined sugars trigger. The pods also contain significant amounts of lysine, an essential amino acid almost completely absent from corn and wheat. They provide calcium, magnesium, iron, and zinc. They're rich in prebiotic fibers that feed beneficial gut bacteria. One researcher described mesquite pods as a complete food that just happens to taste like dessert. For indigenous communities, harvest season was sacred. Families gathered at specific groves, often traveling from summer camps to traditional harvesting sites that had been used for generations. The pods were never picked from the ground, too much risk of contamination or insect damage. Instead, families used long poles to shake the branches, collecting only the pods that fell fresh. These were spread in the sun to dry, then stored in clay jars or tightly woven baskets. Processing required heavy grinding stones called metates. The dried pods were ground into fine flour, a process that could take hours of work. The resulting meal had a complex flavor profile, notes of caramel, cinnamon, mocha, and smoke, earthy and sweet simultaneously. This flour kept for months without refrigeration. It could be mixed with water to make atoli, a warm, sweet porridge. It could be pressed into cakes that lasted through winter. It could be mixed with other flours to make bread. It sweetened drinks and enhanced stews. And it required no plantation, no irrigation system, no slave labor, no infrastructure beyond what the tree provided freely. When Spanish explorers first encountered mesquite in 1535, they were stunned. Elvar Núñez Cabeza de Vaca wrote of people who ate a powder made of straw that tasted like honey itself. He watched families grind pods into meal, baking cakes that sustained them through seasons when nothing else grew. By 1541, other explorers recorded mesquite forests, bosques, stretching for miles along the Rio Grande. Dense canopies creating shade so deep that temperatures dropped 15 degrees beneath the branches. Entire villages living under mesquite protection, harvesting tons of pods annually. The tree gave food, it gave shade, it gave medicine. The black gum dissolved in water treated eye infections and stomach ailments. It gave firewood that burned hot and clean. It gave construction material for ramadas and fences. And it asked for nothing. No water beyond what fell from the sky. No fertilizer. No pesticides. No human labor except harvesting what it offered freely. This was the tree Europeans encountered. Not a weed. A civilization's foundation. The war against free food. By the late 1800s, the narrative changed completely. Mesquite wasn't the tree of life anymore. It was the enemy. The shift coincided with the arrival of large-scale ranching operations. As the United States completed its conquest of the Southwest, vast territories were converted to cattle production. Ranchers claimed millions of acres, fencing off land that had been communal for millennia. Their business model was simple: maximize grass production, maximize cattle numbers, maximize profit. Anything that wasn't grass was waste. Anything that competed with grass was the enemy. Mesquite, which had evolved to thrive in disturbed soil, exploded across overgrazed rangeland. Cattle trampled the ground, creating perfect germination conditions for mesquite seeds. The trees spread rapidly, reclaiming land that had been stripped of its original vegetation. Ranchers didn't see ecological succession. They saw theft. They believed mesquite roots were stealing water that should go to grass. They believed mesquite thorns were injuring livestock. They calculated losses in acres of grass replaced by worthless trees. The language became militaristic. Mesquite wasn't just a problem. It was an invasion, an infestation, a plague. They called it the green cancer. The eradication campaigns began in earnest. Millions of acres were targeted for clearing. The methods were brutal and expensive. First came mechanical removal. Workers used axes, saws, and eventually bulldozers to cut mesquite to the ground. They poured diesel fuel on the stumps and set them on fire. They used massive steel chains, hundreds of feet long, dragged between bulldozers to rip entire forests from the earth simultaneously. But the ranchers made a fatal miscalculation. They didn't understand mesquite biology. Just below the soil surface, mesquite possesses what botanists call the root crown. This structure contains dozens, sometimes hundreds, of dormant buds. These buds remain inactive as long as the tree is healthy, but when the trunk is severed, they activate immediately. For every single trunk cut down, 10 new shoots erupted from the base. What had been majestic single-trunk trees became dense, impenetrable thickets of multi-stemmed growth. The more ranchers fought mesquite, the denser it grew. Desperate, they escalated to chemical warfare. In the mid-20th century, herbicides flooded the market. 2,4,5-T, a component of Agent Orange, was sprayed across the American Southwest. Massive aerial campaigns dumped thousands of gallons of poison onto mesquite forests. The United States Department of Agriculture promoted these campaigns. They published bulletins describing mesquite as a range pest. They funded research into more effective killing methods. They provided cost-share programs to help ranchers afford the chemicals. Extension offices distributed pamphlets with titles like Mesquite Control for Increased Production. University experiment stations tested new herbicide combinations. The language was clinical: brush control, range improvement, eradication. Nowhere in these official documents was there mention that mesquite had fed people for 4,000 years, that it was still feeding indigenous communities, that its pods were more nutritious than most crops, that its presence indicated healthy soil rather than degradation. The economic logic was clear. Mesquite had no commercial value in a system built on commodities. You couldn't sell mesquite pods at the Chicago Board of Trade. You couldn't ship them across the country in refrigerated railcars. You couldn't build an industrial supply chain around a wild food that grew freely without anyone owning it. Meanwhile, industrial sugar from cane and beets flooded American markets. Cheap, standardized, infinitely profitable. Sugar plantations in Hawaii, Louisiana, and the Caribbean produced millions of tons annually. Beet sugar from the Midwest added millions more. These industries were backed by massive capital investments, refineries, transportation networks, marketing campaigns, political lobbying. They needed consumers dependent on their product, not gathering free sweetness from desert trees. Mesquite's existence as a free alternative threatened that model. Not significantly, most Americans would never eat mesquite regardless. But symbolically, its presence contradicted the narrative that sweetness must be purchased, that food requires industrial production, that survival depends on markets. So mesquite had to be reclassified, from food to weed, from ally to enemy, from resource to pest requiring elimination. The propaganda was effective. Within a generation, most Americans believed mesquite was worthless. Even indigenous communities began abandoning traditional foods under pressure to assimilate, to eat American food, to participate in the cash economy rather than subsistence harvesting. By the 1940s, after decades of eradication efforts, the USDA quietly admitted failure. Mesquite could not be killed. The 1948 report concluded that complete eradication was impossible and that control efforts would need to continue indefinitely. But the damage was done. Millions of acres had been cleared. Ancient groves were gone. The knowledge of harvesting and processing had been interrupted for an entire generation. Children grew up learning that mesquite was trash, not treasure. The land remembers. While the war raged above ground, the consequences played out in the soil. Without mesquite canopies, temperatures soared. Bare ground absorbed and radiated heat that had previously been moderated by shade. Grasses, which ranchers were trying to protect, began dying from heat stress. Without mesquite roots holding soil structure, wind and water erosion accelerated. Topsoil that had taken centuries to develop blew away in dust storms or washed into gullies. The ground cracked and hardened into caliche. Without mesquite's nitrogen fixation, soil fertility collapsed. The grass that did survive became nutritionally poorer, supporting fewer cattle per acre than the diverse ecosystem had supported before clearing. Rivers that had flowed through mesquite bosques dried up. The tree's roots had helped capture and slowly release monsoon rains. Without them, water ran off rapidly, causing floods during storms and drought between them. Cattle, the animals ranchers had tried to protect, began starving. Herds had to be reduced. Grazing permits were cut. The promised wealth from improved rangeland never materialized. By the 1920s and 1930s, government surveys documented the catastrophe. Acres of former grassland reduced to hardpan. Livestock numbers plummeting year after year. Field reports noted increasing difficulty controlling mesquite, which kept resprouting from deep roots even after repeated treatment. But it took until the 1970s for science to catch up with what the desert had been screaming all along. Ecologists studying desert recovery noticed something remarkable. Wherever mesquite returned, the land healed faster. Under mesquite shade, native grasses and wildflowers reappeared when nothing else would grow in the open. Soil samples revealed the mechanism. Mesquite roots host rhizobia bacteria capable of nitrogen fixation. These bacteria pull nitrogen from the air and convert it into forms plants can use. Effectively, mesquite fertilizes the soil around it continuously. Measurements showed soil beneath mesquite canopies contained significantly more nitrogen, more organic matter, more moisture, and more microbial activity than adjacent bare ground. The trees weren't stealing from the land, they were feeding it. The term, keystone species, entered scientific vocabulary to describe organisms like mesquite. Remove the keystone and the entire arch collapses. Remove mesquite and the desert ecosystem loses its foundation. Further research documented mesquite's role in the broader web of life. Over 60 species of native bees depend on mesquite flowers for pollen. Quail, deer, javelina, coyotes, and countless smaller animals rely on mesquite pods as food. Birds nest in mesquite branches. Reptiles shelter in mesquite shade. The iconic saguaro cactus, symbol of the Sonoran Desert, often cannot survive its first decades without growing under a mesquite nurse tree. The shade and moisture modification that mesquite provides creates the microclimate saguaro seedlings require. Studies showed that biodiversity was higher in areas with mesquite than in areas without it. Species richness, abundance, and ecological interactions all improved with mesquite presence. The tree that had been called green cancer was actually the immune system of the desert. Its removal had made the land sick. Its return was healing. But by the time science confirmed this, The damage to Mesquite's reputation was complete. The research existed in academic journals that ranchers didn't read. The findings were published but not popularized. The narrative of Mesquite as pest persisted in the culture even as the evidence proved it wrong. The sugar that heals. While ecologists were discovering Mesquite's environmental value, nutritionists were uncovering its medical significance. By the year 2000, global sugar consumption had exceeded 170 million tons annually. Type 2 diabetes had become a pandemic, particularly devastating indigenous communities in the Southwest who had shifted from traditional diets to modern processed foods. The Tohono O'odham, who had virtually no diabetes before the 1940s, saw rates soar to over 50% of adults by the 1990s. The Pima had similar trajectories. Communities that had thrived on mesquite and traditional foods for millennia were dying from diseases of modern diet. Researchers began asking uncomfortable questions. What had changed? What had been lost? In 2005, scientists at the University of Arizona conducted comprehensive nutritional analysis of mesquite pods. The results validated what indigenous knowledge had maintained all along. The sweetness in mesquite comes primarily from fructose, but it's not free fructose like in high fructose corn syrup. It's bound in complex carbohydrate structures alongside soluble fiber, specifically galactomannan gum. This gum forms a gel in the digestive tract, dramatically slowing the absorption of sugars. Instead of spiking blood glucose rapidly, mesquite releases energy slowly and steadily over several hours. Clinical trials with diabetic participants showed that replacing refined flour with mesquite flour in tortillas, pancakes, and baked goods resulted in significantly lower postprandial blood glucose spikes. Some participants reported being able to reduce insulin requirements when mesquite became a regular part of their diet. The glycemic index measurements confirmed it. Mesquite flour scored approximately 25, less than half that of whole wheat bread. This meant people could enjoy sweetness without the metabolic damage that refined sugars inflict. But the benefits extended beyond blood sugar control. The prebiotic fibers in mesquite, fructooligosaccharides and galactomannans, feed beneficial gut bacteria. Specifically, they promote bifidobacteria and lactobacillus species while inhibiting pathogenic bacteria. Studies showed that regular mesquite consumption improved gut microbiome diversity, enhanced mineral absorption, and reduced inflammatory markers. The tree that fed the body was also healing it at the cellular level. The protein content was equally impressive, at 10 to 30% depending on the variety and growing conditions. Mesquite pods contain more protein than many grains, and unlike most plant proteins, mesquite contains significant lysine, an essential amino acid that's the limiting factor in corn and wheat nutrition. This means mesquite doesn't just provide empty calories. It provides complete nutrition: protein, complex carbohydrates, fiber, minerals, and bioactive compounds that modern nutrition science is only beginning to understand. One researcher noted the bitter irony: we spent millions trying to destroy the one plant that could treat the diseases caused by our modern diet. By 2010, this research had filtered into health food markets. Mesquite flour began appearing on shelves, marketed as a superfood. Prices jumped to $15 to $20 per pound. Suddenly, the worthless weed was a premium product. Chefs in Santa Fe, Tucson, and Phoenix began experimenting with mesquite in high-end restaurants. Its complex flavor profile, notes of cinnamon, caramel, mocha, and smoke, made it interesting to culinary innovators. Mesquite pancakes, mesquite ice cream, mesquite-crusted meats appeared on menus. The tree that had been poisoned was now being celebrated. But this commercial revival, while economically interesting, wasn't where the real return to mesquite was happening. The movement to remember. The true revival of mesquite began quietly, in communities that had never completely forgotten. Around 2012, indigenous farmers, elders, and food sovereignty activists across the Southwest started a movement they called Reclaiming the Forgotten Tree, not as a health trend, as cultural restoration. Organizations like the San Javier Co-op Farm on the Tohono O'odham Nation and Desert Harvesters in Tucson began coordinating community harvests. They revived traditional gathering practices, teaching younger generations how to identify the sweetest varieties, when to harvest, how to process properly. They rebuilt community milling stations where neighbors could bring gathered pods to be ground by shared hammermills, recreating the communal labor that had been standard for millennia. They shared recipes that had nearly been lost: atole, the warm sweet porridge, pinole, the energy-dense travel food, mesquite cakes pressed and dried for storage, mesquite tea brewed from the pods. A Tohono O'odham farmer who participated in these revivals explained, "When we eat the food of our ancestors, we remember who we are. The tree never left us. We left the tree, but it was patient. It waited for us to come back." By 2018, community seed banks in Tucson and Hermosillo began systematically collecting and preserving mesquite varieties. Botanists identified over 30 distinct regional varieties, each adapted to specific microclimates, each with slightly different flavor profiles and pod characteristics. Some produced dark red pods that tasted intensely of molasses. Others produced pale gold pods with subtle vanilla notes. Some were optimized for protein content, others for sugar. This diversity represented thousands of years of natural and human selection, a genetic library that industrial agriculture had almost erased. The movement spread through social media, community workshops, and traditional knowledge sharing. Young people who had grown up eating processed food began learning to harvest mesquite. Food sovereignty became linked to cultural identity, to resistance against industrial food systems, to reclaiming autonomy. This wasn't nostalgia. This was practical adaptation to a changing world, because by 2020, the context for mesquite had shifted again. The future that's already here. Climate change removed any remaining doubt about mesquite's relevance. Droughts across the American Southwest broke records year after year. The Colorado River dropped to levels not seen in centuries. Reservoirs that supplied water to millions shrank toward dead pool. Agricultural regions that depended on irrigation faced mandatory cutbacks. In California's Central Valley, which produces 25% of America's food, fields were fallowed. Crop yields dropped 30 to 40% in drought years. Wells drilled deeper and deeper, depleting aquifers that took millennia to fill. Wheat, corn, cotton, crops that had replaced mesquite, all failed when water became scarce. The industrial food system, built on irrigation and predictable rainfall, proved fragile when those conditions disappeared. But mesquite, which ranchers had spent a century trying to eliminate, thrived. Its deep roots accessed water no irrigation system could reach. It produced abundant pods even in years when rainfall was 50% below normal. NASA scientists studying climate-resilient crops took notice. Mesquite's root architecture, its CAM-like water conservation strategies, its nitrogen fixation capability, all made it a model for dryland agriculture in a warming world. Research programs explored mesquite cultivation not as a pest to control but as a crop to optimize. How to select for higher-yielding varieties. How to process pods more efficiently. How to integrate mesquite into permaculture systems that rebuild soil while producing food. In 2021, Mexico's National Forestry Commission launched a massive mesquite reforestation program, planting across 300,000 hectares of degraded land. The goal wasn't timber. It was ecosystem restoration and food security. Similar programs emerged in Argentina, where the Algarrobo, Prosopis species, had been similarly suppressed and was similarly resilient. In Kenya and India, where Prosopis juliflora grows, farmers began viewing it as a resource rather than a problem. The Food and Agriculture Organization labeled mesquite a forgotten crop of survival, recommending its integration into food security strategies for arid regions worldwide. Because the reality is unavoidable. The deserts are expanding. Climate zones are shifting poleward. Regions that were marginal for agriculture are becoming impossible. Water is becoming more precious than oil. In this future, mesquite isn't a weed. It's a blueprint, a demonstration that food production doesn't require massive inputs, that sweetness doesn't require plantations, that survival is possible in conditions where industrial agriculture fails completely. The tree that was poisoned may become the tree that saves us, not because we discovered anything new, but because we finally remembered what we tried so hard to forget. What was buried, what returns. For 4,000 years, mesquite fed people without demanding anything. It gave sweetness without slavery. It produced nutrition without depleting soil. It survived every drought, every fire, every change in climate that occurred during the rise and fall of civilizations. Then in less than a century, it was reclassified as worthless. Millions of acres destroyed, knowledge suppressed, an entire food system nearly erased because it couldn't be commodified, couldn't be controlled, couldn't be turned into a supply chain that someone could own. But the tree survived, not because we protected it, despite our attempts to eliminate it, The roots went deeper than the herbicides. The seeds outlasted the bulldozers. The knowledge persisted in the hands of people who never forgot. Now, as the systems built on control and scarcity begin to fail, Mesquite returns, not as a trend, as necessity, as the answer to questions we're finally asking. How do we produce food without depleting water? Mesquite already knows. How do we create sweetness without metabolic disease? Mesquite has the answer. How do we restore degraded land while feeding people? Mesquite does both simultaneously. The wisdom we need isn't in laboratories. It's buried in clay jars, waiting in the dark for 4,000 years. It's growing in the roots that refuse to die. It's preserved in the memories of people who never abandoned what their ancestors knew. This is veiled earth, where we uncover what was deliberately hidden, where we remember what we were taught to forget. If this story took root in your mind, help us grow. Subscribe and share, because every person who learns that the weed in their yard was once called our sugar becomes harder to control. Every person who plants mesquite instead of poisoning it threatens industries built on dependence. The earth has many secrets left to tell. We just have to be willing to listen. The next vault opens soon.